A simple problem for practice. So on the board, I have a problem which might look somehow complex at first, but if you use Fubini's theorem to split it into two single integrals, then it will be really easy after using integration by parts. So let's see how we solve this integral. So basically, we have some of the terms in x and some in y, and they are just independent of each other. So let's separate them. We have tan inverse x square by x square dx. On the other hand, we have integral from 0 to infinity of tan inverse y to the power 4 by y cube dy. And now let's solve this. This will be, if we use integration by parts, we will have a u, and then integral of x square is minus 1 by x, minus integral of, now derivative of this thing is 1 by 1 plus x to the power 4 times 2x, and the integral will be minus 1 to the power x dx. And the x cancels out. Now this will be, and this is from 0 to infinity. So at infinity, tan inverse infinity will be pi by 2, but infinity denominator will make this term 0. And when it's 0, we have tan inverse x square by x at 0. And if we use limits, because it's 0 by 0 form, tan inverse x square will just be x square. Let me do it. So after this, we have minus minus as plus. And over here we will have limit x tends to 0 of tan inverse x square by x. And minus, we will have some other things, and minus minus will be plus, and we will have 2 times 1 by 1 plus x to the power 4 dx. Now over here, we can write it like x square and then also x over here. Now a limit something tends to 0 for tan, let's say if we can write here x square tends to 0, tan inverse x square by x will just be 1, and 1 times here we will have 0, so this is just 0, and plus we have 2 times. Now if we let x to the power 4 as just x, we will be able to solve this using beta gamma function, and this is from 0 to infinity. 0 to infinity. Now we can solve this using beta gamma function. 1 by 1 plus x, and over here we will have 1 by 4 x to the power minus 3 by 4 dx. Basically you can substitute x to the power 4 as y, and again make y as x. So that's what I have done here. And now this will be 1 by 2 integral from 0 to infinity of x to the power 1 by 4 minus 1 by 1 plus x dx. And now this is just beta function of 1 by 4, and 1 minus 1 by 4 is 3 by 4. And now we can find this. This will just be 1 by 2 gamma 1 by 4, and then gamma 1 minus 1 by 4 by gamma 1. And now for this you can use reflection formula. If you use reflection formula, this will just be pi by sine n pi, and n is 1 by 4 over here, so that's sine pi by 4, and this comes out to be 1 by 2 times pi by 1 by root 2, and that leads us to pi by root 2. Similarly, in the other case, we can also use integration by parts over here. So times, if you use integration by parts, we will have tan inverse y to the power 4 and y to the power minus 2 by minus 2. And similarly minus integral, and this is from 0 to infinity. Integral from 0 to infinity, we will have 1 by 1 plus y to the power 4 times 4y cube Yeah, and integral will be 1 by minus 2 y square dy. Okay, and next this will be somehow similar as earlier. At infinity this will just be 0. At 0 also it will be 0. Similar idea. Over here we will have plus 4 by 2 is just 2. Integral from 0 to infinity y by 1 plus y to the power 4 dy. Yeah. And next we will have 2 times. Now we can substitute y to the power 4 as y. Okay, but wait, this will be y to the power 8 actually. Yeah, because we already have y to the power 4 over here, so this will actually be y to the power 8. Y to the power 8. Yeah, and now we will have 2 times integral from 0 to infinity. Now this will just be y to the power 1 by 8, and then 1 plus y. Over here 1 by 8 y to the power minus 7 by 8 dy. Yeah. And next we will have 2 times integral from 0 to infinity and by 8 over here, and this will be y to the power minus 6 by 8, that's y to the power minus 3 by 4 by 1 plus y dy. Now y to the power minus 3 by 4 is just integral from 0 to infinity of y to the power 1 by 4 minus 1. This is same as earlier. Yeah, and then we will have 1 by 4. This will be just a beta function of 1 by 4 comma 3 by 4, and yeah, we already know that is equals to 1 by 4 times pi by 1 by root 2. So this is pi by 2 root 2. Yeah, and now we need to take product of these two expressions. Yeah, for product. Yeah, and now if you take the product, this will be pi square by root 2 into root 2 is 4, so that's pi by 2 whole square. That's the answer. Hope you enjoyed this integral. Answer is pi by 2 whole square, and it was we had a simple problem, just the practicing of the Fibonacci theorem, that we can separate these integrals. And yeah, I hope you enjoyed the solution. Thanks for watching and look forward to seeing you in the upcoming videos too.